Institute and the founder of Boston Dynamics. Please welcome Marc Raibert.
I am so glad to be here. I love robotics. But the reason I'm particularly glad to be here is because this meeting is all about really building stuff. Not just computing, which is great and important, not just doing AI, but making physical things. And I think to some degree the world has lost its focus on the importance of building physical things. So we have thousands of people here who all are somehow involved in building physical things. And you know, robots are a great version of building physical things that also connect up to the computing world. Now my journey started 50 years ago when I went to a conference and saw this robot being shown. It was a conference of biological locomotion people, and this was the only robot being shown. And in one hand, it's exciting to see a robot with all these gadgetry and walking. But I looked at it and thought, wow, it's all wrong. You know, people don't move statically and hug the ground and go slowly so that they don't have any kinetic energy that might tip it over. People and animals could you back up? For some reason, it's not just playing. Could you back up and play that? People and animals use the dynamics of their motion when they're climbing and balancing and moving through the world. And I wanted to somehow embrace that. And over the years, we were able to build robots like this one. For some reason, the videos aren't playing. Could you see if you could play them? They did during the rehearsal. Well, you've probably seen these videos on YouTube anyway. They're mostly from YouTube. This is a robot that can climb through the woods, balancing itself. It has gyroscope or IMU on board that lets it sense its motion through space when it's there we go. So here's an example of a just incredible capability of biological systems. And there's just nothing statically stable about a machine like this. The compliances are all important, the dynamics are important, the actuators, the sensing. Here's two animals running for their lives. The gazelle in order to stay alive for the next 20 minutes, and the cheetah who hopes to get a meal so it can stay alive for the next period. And look at the capability of my grandson at just 2.5 years old in terms of physical capability coordinated with perception and planning. It's just remarkable what's going on in nature. There we go. So we've been working at Boston Dynamics and now with the Robotics and AI Institute to capture some of the things that biological systems have and to build machines that are much more capable than just a machine by itself can be. I'm sure many of you have already seen this robot, Big Dog, which was really a turning point in the life of Boston Dynamics when we went from just doing researchy work to something that you could imagine being out there in the world doing useful work. And that evolved largely with funding from DARPA and the other government agencies in order to build that machine, which can carry a large payload out in the bush. It doesn't have to be driven. Here it's following a human leader using a visual system. And of course, if you ask, why do we care about legs? Legs can go places where wheeled and tracked things have a very hard time going. You don't have that in Houston, but we in Boston face that all the time. This is the fastest legged robot. It gets up to about 20 miles an hour. Actually, I just saw a video that claims a faster speed than that. but for a long time this held the record. And you can see it's all about the dynamics and the control and the stability, but also building hardware that supports that kind of very energetic behavior. I'm going to give a quick recap on what's going on at Boston Dynamics now, and then turn to the Robotics and AI Institute, which is my current passion. There's really three main projects going on at Boston Dynamics, and I'm just going to talk about two of them, Spot and Atlas, and you can look up work on Stretch if you like. So Spot is a quadruped robot. You saw it at the opening, and we're going to have it back out here in a couple of minutes. That is made really as an experiment. When we first decided to commercialize Spot, we didn't know how it was going to be used. So the early people to buy it were academics who did research with it, or innovation labs, like maybe some of you are from. And then now it's used largely for industrial inspection, doing 3D mapping of environments. There's some police force use of it to intermediate between people in dangerous situations. And these are some examples of how it's used. This is on used by British Petroleum in a refinery and on an oil rig. And the ability of the robot to go over terrain is one of the key features, mediated by cameras and other sensors that allow it to see its environment and adjust its behavior to do that. This is an integrated circuit fabrication facility that I worked at 50 years ago when I was a co-op student at Northeastern University. And it's really exciting that we've gone full cycle, and now my robots are working there, inspecting equipment and doing things like that. It's also being used at nuclear facilities where they're doing remediation, such as Chernobyl. At least before the war, it was at Chernobyl, and 3 Mile Island and a number of other places. It's really great for hazardous environments, industrial inspection, as I said, law enforcement, and other things. There's about 2,000 of them out there now, and the sales are really going great. So we're going to have a demonstration. You saw a little bit of Spot before. And this is Forrest Gibson, who has an agency that's a talent agent for robots. And he's supporting us today by having Spot out here. So one of the exciting things about a robot like this is that it's omnidirectional. It can turn in a circle like you see now. It's got cameras on both sides, and on the front and on the back. It can move sideways. It can avoid obstacles. I'm going to be an obstacle. And you'll just have to trust that Forrest didn't do that. He just said, drive straight ahead, and then here, how about backing up? We're having a little trouble with the Wi-Fi because so many of you have your phones here. But he's going to tell it to back up. But the robot's smart enough to see me and say I'm not supposed to go there and walk around. Now this robot was designed as a platform. Now it's showing off. Okay, stop showing off for a second. This was designed as a platform. Can you bow it face down? And we have a roof rack on it so that you can design your own equipment and attach it. Boston Dynamics sells equipment to attach, but then third parties build sensors and other kinds of things that you can just strap on here. There's also a place to plug in to the computers so that you can work through the API and have your platform, talk to the robot, tell it what to do, or listen to what the robot's telling it, things like that. Great. Okay, go away. It's been hard having Spot as a partner, because people would rather see Spot